This video is on predicting synthesis products, which if that sounds like a completely foreign language to you, you should probably go and watch the videos on balancing chemical reactions and types of chemical reactions because you'll need to know how to do all of those things before jumping into this. Predicting synthesis products, they're probably the easiest kind of product to predict, probably like a 3 out of 10 difficulty. So let's get started. First off, synthesis reactions are also called combination reactions. And we know that whenever we're combining, we're just putting things together. So we know that in a synthesis reaction, we're going to have 2 reactants and we're going to combine them into one product. Our synthesis reactions are going to look like this. We're going to have a metal reactant plus a non-metal reactant, and our product is going to be a balanced ionic compound, okay? So we know that whenever we're predicting the products to these synthesis reactions, our prediction should be a balanced ionic compound. So we're gonna jump right in with an example here. And I see that I have magnesium, which I know is a metal, and then oxygen, which I know is a non-metal. So now I know that this is a synthesis reaction, and my result should be a balanced ionic compound. So first off, I'm just going to write Mg and O. Now, I'm going to put my charges. I know that magnesium is a 2+ and oxygen is a 2-, and we got lucky, and this already balanced out, so we don't need any subscripts. Okay? So this is going to be our product, but we're not done. If I look over here, I have one magnesium, but here I have 2 oxygens, and I only have 1 oxygen here. So I'm going to make this oxygen a 2. I can't change subscripts, so I'm just going to put a coefficient. All right, so now I have 2 oxygens and 2 oxygens, but now I have 2 magnesium and only 1 magnesium. So I'm going to put 2 right here, okay? Now let's double check this. 2 magnesium, 2 oxygen, 2 oxygen. We predicted our product and then we balanced it. Super simple. Now, this is a bit trickier of a thing. You really just need to understand the concept of this. We'll do a practice problem for each, but this requires more of a knowledge than what you probably have in your chemistry class right now, which I'll explain what that means in a second. But first, some non-metal oxides react with water to form an acid, okay? So we're gonna use this example right here, where we have this sulfur and this oxygen, which is a non-metal oxide because sulfur is a non-metal, and it's going to react with water to form an acid right here. Now, I know that all acids start with H. That's what makes them an acid, so I'm gonna put my H right here. Now, this is where it gets tricky because normally you wouldn't look at your subscripts, you would just look at the elements and how to make them a balanced ionic compound. But here, we're looking at the number of atoms that we have for each of these things because we're going to be forming a polyatomic. So if I look here, I have a sulfur, and then I have 3 oxygens. So I'm going to put SO3. Now, if I look at my polyatomic ion chart, or I Google it and I look it up, I know that SO3 is going to be sulfite, and it's going to have a 2- charge. Now I know that hydrogen has a 1+ charge, so this is not balanced, so I would need a 2 here to balance that. Okay, so this is going to be our new balanced acid. What we did was we took this non-metal oxide and we added our water and we just totaled up the number of atoms we have in everything, and this turned out to be our balanced ionic compound. Now, if I look over here, I have 2 hydrogens, 1 S, and then 2 + 1 is 3 oxygens, okay? So you probably won't do as much practice with this just because you'd have to know, well, if you had this, an N2O5, and you were adding water, you'd end up with 6 oxygens, okay, to go with this. But instead of having this N2O6, once you add your oxygen from the hydrogen, you would have 2 NO3s. And the only reason that you would know that is because you have to know what things actually work in chemistry. And this N2O6 would not, but an NO3 would. This N2O6 would be neutral, but the NO3 would have a 1- charge. So that's why this is a bit trickier. This is the correct way to do this problem, but just because these problems are so funky, you probably won't have to do a lot of practice problems, or you probably won't be asked to do these on tests or quizzes or anything. You just need to know that some non-metal oxides react with water and they form an acid, okay? So now we're gonna move on to the second funky thing. some metallic oxides react with water to produce a base. So I go over here. I see my oxygen, I know I'm looking at an oxide, and then I look at calcium and it's a metal. So this is a metallic oxide reacting with water, so I know that I'm going to end up with a base. Now I know that bases, what makes an acid is that it starts with hydrogen. So my bases I know are going to end in hydroxide, which is this OH. Okay, so that accounts for my oxygens and my hydrogens. And now over here, I need to put my calcium. Now I know that calcium has a 2+ charge, and I know that's supposed to be plus. And I know that my hydroxide has a 1-, so this is not balanced. I'm going to need 2 of these OHs. So now I am balanced because this is a 2+ and this is a 2-. Okay, so now I'm going to look over here to make sure I'm balanced, and I have 1 calcium, 2 oxygens, 2 oxygens, and 2 hydrogens, 2 hydrogens. Now, again, these are a lot funkier than our normal balancing, especially because we don't have just an element and another element. So just know that non-metal oxides react with water to form an acid, and metallic oxides react with water to produce a base. The main thing that you need to worry about is these top things and how to practice them like that. That's what you're most likely going to see whenever you're given like practice problems and stuff on predicting synthesis products. So I hope this helped.